In the last video, we looked at a planned comparison between two treatment means as a follow-up to doing an analysis of variance. And in this video, I'm going to look at unplanned comparisons as a follow-up analysis to an analysis of variance. So we're going to work with an example that was looking at carbon transfer between birch trees and Douglas fir. And if we look at the data, we've got 15 experimental units here. 5 of them were in deep shade, 5 in partial shade, and 5 in no shade. And the response variable is measuring the net amount of carbon transferred from the birch to the Douglas fir in milligrams over the study period. Okay, so first step is we have a categorical variable, and so I'm going to turn it into a factor so that I can put the levels into the order that will be most meaningful for my analysis. So I'll do that, and then we can look at some summary statistics. So there's the sample means and the sample standard deviations, and then we can look at a strip chart of the data with the means plotted as the filled-in circles, and then we've got standard error bars as well coming off the group sample means. So we can see that the trees in deep shade seem to have a higher net carbon transfer than both the trees in the partial shade and the trees with no shade. But there's not a huge difference between the partial shade treatment level and the no shade treatment level. So let's do an analysis of variance. So step 1, state the null and the alternative hypotheses. Null hypothesis is that the treatment means are all the same. Alternative hypothesis is that at least one treatment mean is different from the others. Test statistic. Well, if we fit the linear model and look at the analysis of variance table, we can see the F test statistic right there, 8.7841. Third step, the p-value is 0.004468. Step 4, we will reject the null hypothesis in favor of the alternative because 0.004468 is less than a significance level of 0.05. So our conclusion is that at least one treatment mean is different than the others. Now let's consider unplanned comparisons for this example, because we have determined that at least one mean is different from the others, but we do not yet know which means are different from each other. So that's what unplanned comparisons are going to do. There's many different types of unplanned comparisons, and the method that we're going to use is called the Tukey method. And the way that we apply it is to use the EM means function. So just as we did in the last video when we did a planned comparison. And then when we use the contrast function for unplanned comparisons, we need to set the adjust argument to the method of unplanned comparisons that we want to do. And because we're doing Tukey-Kramer, we use Tukey in here for the adjust method. And then if we just look at the output for that, there's a lot going on here. So let me walk us through this in a little more detail. So if we look at the first row of that table, that row tells us the results of a hypothesis test where the null hypothesis is that the mean for the deep shade trees is the same as the mean for the partial shade trees, versus the alternative hypothesis that those means are different. The test statistic for that hypothesis test is 3.067. It's labeled as T ratio in this output, but the book refers to this as Q, the Q statistic. Third step is the p-value. There it is, 0.0246. Fourth step, we're going to reject the null hypothesis in favor of the alternative hypothesis because 0.0246 is less than 0.05. So our conclusion is that the deep mean is different than the partial mean. We'll do the same for this row of the table. So I'll cut to the punchline. Our test statistic is 4.008, which has a p-value of 0.0046. 0.0046 is less than 0.05, so we reject the null hypothesis in favor of the alternative hypothesis that the population mean for the deep treatment level is different than the population mean for the no shade treatment level. And then finally, the third row, there's our test statistic, there's our p-value. In this case, our p-value is not less than 0.05, so we cannot reject the null hypothesis. The null hypothesis states that the mean for the partial shade trees is the same as the mean for the no shade trees. So we cannot reject that null hypothesis. So coming back to the strip chart here, does that seem to jive with our Tukey Kramer tests? So one way that we can summarize what we just determined using the Tukey Kramer tests is to assign letters to the different levels according to whether or not we were able to reject the null hypothesis in each case. So let's go through this one by one. In the deep versus partial, so we're comparing this treatment level with this treatment level, we rejected the null hypothesis. And so if we assign letters to these different treatment levels, we need to assign different letters because we determined that the group means, the treatment means, were different. So different letters for different treatment means. So we could assign the letter A here and B here. Let's do the next one. Deep versus none. Deep versus none. Actually, I'm going to do this one first. Let's do partial versus none. So we've given the letter B to the partial treatment group. We did not reject the null hypothesis for this comparison, for this contrast. So that means that we need to give the no shade group the same letter as the partial shade group. So we've already written B here, so we'll write B here as well. So we've got an A here, a B here, and a B here. Now I'll come back to this middle one because we rejected the null hypothesis here. We concluded that the means for the deep shade group and the no shade group were different, and so we need to have different letters for those two treatment levels. And we do have different letters. We've got an A here and a B here. So that would be one way to summarize the results of the Tukey Kramer method that we've just used here. We've got this group is A and these two groups, or these two levels, are B. Again, it can be helpful to go through the hand calculations because it gives you a little bit more insight into what's going on. But in practice, once you know what's going on, just use the built-in functions. So do the analysis of variance test, and if your study design is such that you don't have a specific planned comparison to do, then at this stage, after you've done the analysis of variance and rejected the null hypothesis, so you've determined that at least one treatment mean is different from the others, then you can go and do your unplanned comparisons. And if you use the Tukey method, the Tukey Kramer method, you use Tukey for the argument here, and then you get your table of results, and then you can go through each different contrast and determine whether you're going to reject or fail to reject the null hypothesis in each case. And then you can summarize your results with this kind of graph, and you can annotate it as in this example with a A here and a B here and a B here.